synthetic division with polynomials is similar to what we did with long division with polynomials. Synthetic division is just meant to be quicker. You're taking out all the x's and just writing the bare minimum, all the number crunching that you'll have to do, but you're getting rid of all that extra writing that you don't really need. So I want to do an example where we do it once with long division, and then I'll show you what it looks like with synthetic division so that you can compare the two. So long division, we would have our x minus 4, and then inside our doghouse, our division doghouse, we'd have 2x cubed minus 7x squared minus 8x plus 16. Then when we start in with our long division, we need to multiply by a 2x squared and work backwards with your arrows. 2x squared times x is 2x cubed, and 2x squared times negative 4 is negative 8x squared. Remember to change all the signs, so this one's negative, here we have a positive. These terms go away, our x cubed terms, and we're just left with a positive x squared at the bottom here. Drag down your next term, x squared minus 8x. We now need to get x to look like an x squared, which means we multiply by a positive x. And when we work backwards, we'll have x squared minus 4x. When you do your long division, we have to switch the signs. So our x squareds disappear, and over here we'll have negative 4x. Drag down that last term, plus 16. To get to negative 4x, we had to multiply by a negative 4. Distribute that negative 4 back out. So we'll have positive 4x here. Oh, sorry, negative 4x. And positive 16. But when we subtract, we have to switch those signs. So this does become a positive, and this is a negative. And both of those terms go away. We have 0 as a remainder. And our final answer is right up here at the top, 2x squared plus x minus 4. Okay, that's long division. That's comfortable, we got that. Now I'll show you synthetic division. But before we do that, we have to know there's a certain way it has to be done. And these important notes up here. Synthetic division can only be used when the divisor, and we'll talk about what the divisor is in the form x minus k. So write that, and then I want you to circle it and point an arrow right here. This is our divisor. And it makes sense because divisor, that's what we're dividing by. And you'll see that it's in this form, right? We have the x and we have the minus symbol. And so that means k is 4. Now when we set up synthetic division, k comes first. We're always looking for k because that goes on the outside of our division problem, our long division problem. Inside is going to be different than what we've done in the past. We're taking all of these terms and writing them without their x's. So we're just writing the coefficients. So at the beginning we'll have 2 instead of 2x cubed. We'll have a minus 7, a minus 8, and a 16. We just took out the x's, that's all we did. And if you want to keep the positives, that's fine. Draw a little bar right here, and then another little bar. What's going to happen is at the end, whatever's left over here, that's your remainder. Okay, now we got to do some number crunching. The rules of synthetic division. Whatever's first, you drag it down and repeat it. So 2 just gets rewritten down below this bar. Then, every time you take whatever's down here on the bottom, you're going to draw a diagonal arrow up to the next spot. And when you draw that diagonal arrow, you're multiplying by k. And in this case, our k is 4. So we multiply by 4, we get positive 8. Then you add up the whole column. So negative 7 plus 8 is 1. Once again, we're going to keep drawing another diagonal arrow. So we multiply it by 4. 4 times 1 is, or 1 times 4 is 4. Add up the column. Negative 8 plus 4 is negative 4. Last time, multiply by 4 again, multiply by k. Negative 4 times negative 4, or negative 4 times 4, sorry, is minus 16. And when you add up that column, 0 is your remainder, which is good because we know we got a 0 for a remainder when we did the problem with long division. The only tricky part now is where's our answer? And what you'll look at is this section right here. Here's our answer, but just like synthetic division, there's no x's in it, so we have to go back and put them in. The minus 4 is fine the way it is. Then we have to put an x here, and you just keep adding exponents. So now here is an x squared. And if we had another term, this one would be x cubed, and it could keep going on and on. But we don't have that. So our final answer is 2x squared, fill in the pluses and minuses, plus x minus 4. So there's your answer. And it is exactly the same as what we got with long division. I certainly hope that should happen. All right, let's do another example. Just synthetic division now. First things first, look for that form, x minus k. And this one is exactly the same as the last problem, actually, because k is equal to 4 again. So when we set up the problem, 4 is on the outside. That's what we're dividing everything by. And inside, we take out all the x's, and we're just left with the coefficients. 26 and negative 24. Okay. Now the legwork comes in. Those lines just help you keep organized. Okay, so 2, we always take that first term and repeat it, just drag it straight down. So the 2 goes here. Then we're multiplying it by k when we bring it back up to the top and draw those diagonal arrows. So 2 times 4 is 8. Add up the column. Negative 13 plus 8 is negative 5. Once again, another diagonal arrow. Multiply by k. Negative 5 times k is 4, so negative 20. And when you add up the column, you'll have a positive 6. Last one, 6 times 4 is positive 24. And so you'll see that the minus 24 and the positive 24 result in 0 as a remainder. Now we have to go back in and fill in our x's. So the 6 is fine. We put an x here, and an x squared goes here. Just keep working your way upwards. So our final answer is 2x squared minus 5x plus 6. It's a lot quicker than long division, if you can get the hang of the format. Okay, let's do another one. Here's a good example because we'll have to use placeholders. I want to set it up with long division, but then we're going to solve it with synthetic division. So if we were going to set this up with long division, we would start with p minus 3 on the outside. And then when we started writing our long division problem, we would see that, okay, p cubed, that's fine. uh-oh, there isn't a p squared. And I taught you today that you put in a 0p squared. It's not changing the problem, it's just helping us do the math right and keep it organized. Same thing, there isn't a p value either, but there is a negative 27 at the end. Okay, that'll help us get the right format for our synthetic division. So synthetic division, we need x minus k, and when we look up here, p, it's the same as the x, minus, so k is 3. Okay, now let's set up the problem. We will have a 3 on the outside, that's what we're dividing by. And on the inside, we're going to use this, everything here, to help us set it up correctly. So the coefficient hiding by the p cubed is a 1. There's 0 p squareds, 0 p's, and minus 27 at the end. Keep yourself organized, draw those lines to help you. First thing we need to do is drag the 1 straight down and repeat it. Then we start in by multiplying by our k's. Each of these diagonal arrows will multiply by k, and k is 3. So 1 times 3 is 3. Add up the column, 0 plus 3 is 3. Another diagonal arrow, 3 times 3 is 9. So when we add up this column, 0 plus 9 is 9. The last one, oops, let's make it red, keep it consistent. 9 times 3 is a positive 27. And when we add up that column, they disappear, we're left with 0. So we once again have a 0 as a remainder, and we have to go back and fill in our x's. So here's a plus, this term will be an x, and this term will be an x squared. Let's rewrite it to make it more neat. X squared plus 3x plus 9. There you go. That's your answer. Let's do one more. This example is what to do when it's not in the proper form. X minus k is what we need. We have x plus 1. That's not going to work. So we need to rewrite it using some little sneaky math here as x minus, we need that minus, but we can't change the answer. But we know that 2 negatives make a positive, so we'll have x minus negative 1. We would never write it like this normally, but that will help us to get it in the right format. So our x's, here's our x from the formula. There's our minus, which means that our k is including that other negative. So k is negative 1. Now set up your synthetic division. Negative 1, k, goes on the outside. And on the inside, we get rid of the x's and just keep the coefficients. A positive 5, a 1, and a negative 7. Write your lines here to keep it straight. Synthetic division, you take whatever's in the first spot, drag it down and rewrite it. So rewrite the 5 down below the bar. Then, when we drag our diagonal arrows, 5 times k, so 5 times negative 1 is negative 5. Add up the column, you'll have negative 4. One more time, we have to multiply by negative 1. We're left with a positive 4. And then we add up this column. Uh-oh, we have a remainder. So we have a remainder of negative 3. It'll be handled very similar to how we handled it in class today with remainders and long division. But first I want to go back and put in our x's. So we know that the first term, our minus 4, that's fine the way it is, but we have to throw in an x in our second term over. So our final answer is 5x minus 4. Here's where you take the remainder, so plus a negative 3, put it in a fraction, and it's divided by the divisor, which sounds silly, but you just divided it by the x plus 1. That's what we were dividing by originally in the problem. Okay. Last example, I want you to finish it. I'm going to help you set it up though. So take a look. We have another situation where it's not in the right format. We need the x minus k or it will not work. So we rewrite this as x minus negative 5. Then it can be in the right form, and k will be negative 5. Set up your long division. Negative 5 on the outside, and on the inside, rewrite everything without the color or without the x's. So 1, 7, and a 10. And they're all positive. Keep organized with these lines here. You do the rest. We'll keep doing more examples of this tomorrow and get in some different types of examples for these problems.